Um, just want also to thank everyone from the Jug, from all your support. I was nominated Regional Java Champion, so I'm very happy. And nothing of this would have happened without these amazing people from the Jug that they do an amazing job. They receive me with open arms, and they help me every path in my journey. So thank you very much, Frank. Thank you, Barry. Thank you, Gene. The rest of the people from the Jug, they're not here. Chandra, you should be here. But without further ado, today we're going to receive Ken. Ken is a Java champion, Java 1 rockstar, band player. What else? Part of the pointers. Wrote many books as well. I think the last one was Help Your Boss Help You.
Yep. Well, I've got Makito Made Clear coming out anytime.
Coincident or no, I read your book.
You're the one.
Yeah.
Oh, wow.
I told you I read your book. I was thinking about I don't remember when it was, about June, maybe.
Oh.
I don't know if coincident or not, I was promoted at work, so I won't say anything else. So thank you very much, Ken, for being here. It's a pleasure to have you again. The stage is yours.
Thank you, sir. We're adjusting the live stream. Maybe I should put a hat back on, right? Yikes. The glare off the head. Is the mic still working? Because the light is off. As long as it's still. Okay. Then we're good. I don't know how on this thing. I don't think this goes up louder.
I think what you have to do is just
It is, but
talk as loud as you can.
really, do I have to talk louder? Okay, I can do that. You may have to remind me, just, give me a thumbs up. Okay, so do you want to, you're happy with the camera and everything?
Share your screen.
All right, share the screen now. So let's do that. Okay, I have to give you a moment of, well, just a little bit of background on this. I was scheduled to be here in March. Now, of course, I wasn't really going to be here. Back then, everything was still remote. But I was going to present this information, this material, basically, in March. And then it turned out I wound up in the hospital. Don't worry about it. It was a stupid side effect of some stupid medication that I'm not on anymore. But the point was, I kept thinking they were going to let me out in time to give the talk, because I kept saying I got to be out of here by, I think it was Wednesday night that week. And they finally just hit one delay after another, and it was like, oh, great, this isn't going to happen. So I'm thinking, who can I get to fill in for me, who can talk about Java and Groovy and Kotlin, because that's really the subject of the talk. And of course, I thought of my friend Venkat Subramaniam, who many of you no doubt know, or certainly even if you don't know him personally, you're aware of him. And he had already texted me when he found out I was in the hospital, saying, offering sympathies, and said, is there anything you could do? And I went, well, funny you should ask. What continent are you on at the moment? Because if you know Venkat, it could be literally anywhere in the world. I don't think he's been to Antarctica yet, but that's probably because I don't think there's a Java users group at McMurdo Station yet. When there is, he'll probably go. At any rate, so I texted him and asked him if he could do it. I said, I gave him my slides. I gave him the GitHub repository. I wasn't really coherent at that time, but I was enough to give him that. And of course, he was very happy to do it. And I thought, well, isn't that nice of him? And then when I got out and I heard what happened, Venkat did what Venkat does, which means he looked through my slides to see what I was going to cover, threw everything away and live coded his own talk, because that's Venkat. And I'm like, wait a minute here. I thought he was doing me this huge favor. And then it occurred to me that I had just asked him to do something he absolutely loves to do. I mean, you know how they say some actresses would, go to the appear at the opening of an envelope, I mean, asking Venkat to speak at a Java user group, come on. And you know, at one of the finest Java users groups in the world. See, I could pander too, you know, and I really like, oh yeah, I'm really twisting his arm here, aren't I? You know, to get him to do this. But then what occurred to me, unfortunately, was some other people in the past who had been replaced by, you know, had a substitute come in and never got their job back. And I'm thinking, I got to do something about this. I got to talk to Frank. We got to set this up again so I can go and fix what I had intended, you know, and Venkat went and messed up. So anyway, first of all, oh, let me get this out of the way. This is the Zoom stuff here. This is my contact information. Now, an earlier version, a slightly earlier version of these slides are already in the GitHub repository, which I will give you a link to in a moment. But I'm going to update them with, I've just updated this so that I'm working with the latest version of all three languages. I'm working with, I added some slides that, well, you'll see. And of course, I added my brand new Mastodon link as well. I'm still there on Twitter, you know, it's waiting for the latest horror by Elon, and then I'll probably leave. But so far, I'm still there. But at any rate, there's my home email address, homepage, blog, Twitter handle, Mastodon link. And for your information, in case you're not aware, every Sunday I put out a new edition of my free weekly newsletter, Tales from the Jar Side. It's hosted on Substack. So you're welcome to take a look at that or not. I mean, it's up to you. There are the books I've written in the past. Rodrigo was kind enough to mention the Help Your Boss Help You one. But you can see I've written about Kotlin and Java and Groovy. So I really have a repository that has all these languages in it. You know, the latest book that'll be coming out, it's already out in beta. I suppose I should have said something about that. Anyway, at Pragmatic Programmers, let's see, there it is. Makito Made Clear is a short ebook. It's like 60, 70 pages, something like that, about the mocks test stubs and spies testing framework Makito, you know. So if you're interested, and that one I should tell you, by the way, if you're interested in this, let me give you a coupon code. It's I don't have anywhere to write it down. It's KK, my initials, Makito, all one word, 35, and that should give you a 35% discount. You could try KK Makito 85 and see if that works. But if you really think it through, though, you try KK Makito 105 and see if they'll pay you to take it away. All right? Yeah, well, we'll see. Any rate, so here's the GitHub repository, or the link for it. And again, the slides that are in the GitHub repository have this link in it, but I'll also give this to Frank and everything. So it's in my own account under my last name, you know, Kousен. It's pronounced cousin, even though it doesn't look like it. I think it's an Ellis Island job, you know. And it's Java_Groovy_Kotlin. And that's everything will be in there. So I'm using the latest versions of Groovy and Kotlin. And on Java, actually, I have a setting in the GitHub, in the Gradle build file, to use Java 17. I have tested it on up through 19, but I'm not using any features really that go much beyond 11, although I do think I have some records in there. So I've got various, but you don't need any of that stuff to follow what's going on here. Speaking of people who go out for some reason and then get replaced, you're in New York, you're probably familiar with the story, but there's a link to Wikipedia about Wally Pipp. Wally Pipp was a first baseman for multiple teams, but he spent many years, 10 years with the Yankees back in 1915 to 25. And the legend has it, this is in the Wikipedia page, that one day he showed up at Yankee Stadium with a severe headache. That he didn't say whether it's hungover, but that's what the rumor is, and asked the trainer for 2 aspirin. And the manager noticed it and said, "Take the day off. We got this kid, Lou Gehrig, to play today and get back in there tomorrow." And of course, Gehrig played the next 2,129 games after that, or it's just crazy. So when I had Venkat substitute for me, I'm thinking, oh, this isn't good. I mean, they'll forget entirely about me. I got to get back in here, get back in the conversation at some point. So at any rate, let's talk about these languages from a functional point of view, because we want to talk about the functional capabilities of all three. Now, first things first, none of them are functional languages. I mean, they are object-oriented languages with functional capabilities that have been added on. And there's a certain amount that's been added on. Now, for this group, I imagine most of you are familiar with the basic capabilities, and then I'll show you what some of the other more advanced capabilities have been added to, say, Groovy and Kotlin. So they all compile to bytecodes on the JVM, which is why I'm able to actually combine them all into the same project. And I can have Groovy test cases on Java code or Kotlin regular code calling Java libraries. You can mix and match to your heart's content. So none are functional languages, but they're all object-oriented languages with various functional features. The nice thing is that's not a conflict. I mean, those are quite compatible. You don't have to do either or. You can do both. So this is kind of a nice thing. You don't lose anything and you only gain capabilities. Now, Java, of course, actually, I didn't update this. I guess it's now 26 years old. You know, it's been a little older than that. Of course, it comes from Oracle and all the different implementations. For the record, I'm using the Eclipse Adoptium implementation of OpenJDK 17. You know, I use that again, not because I necessarily need 17, but I'm on my laptop is a Mac M1 Max, you know, the Apple Silicon chip. Oh, it's wonderful. I really wanted, all I wanted was a machine that let me run Zoom calls without the fan running constantly. And man, I don't even know if this thing has a fan, you know. Actually, there was one thing I ran that triggered the fan. I can't remember what it was. I don't think it was Xcode, but I've heard that's a monster. But at any rate, that's the optimized JVM for this machine. So that's what I'm using. The functional features that most people are familiar with at this point were added in 1.8. Streams, lambdas, method references, the optional data type, static and default methods and interfaces, the works. And while they've refined them over the years, they have not really fundamentally changed the functional capabilities in Java since then. Everything else has been supplements. You know, I mean, seal classes and records and the local variable type inference, none of that has anything really to do with the functional capabilities. They just complement them, and that's fine. The long-term support version is still 17. Presumably next year, we'll go to, of course, 20 in March and then 21 in September. And rumor has it they've moved to a 2-year calendar for the long-term support versions. So 21 will be the next LTS version. And then it'll be interesting to see how many companies are still on 8 at that point. My anecdotal experience combined with a few surveys I've seen from the past few months suggests that roughly 40 to 45% of the community is still on Java 8. About 40 to 45% is right around 11. And then the rest are small fry. They're just noise. But 17 is growing rapidly, but growing from 2% to 5% is growing rapidly. You know what I mean? Anyway, we'll see. Now, Groovy was created as a JVM-based language. It goes back to roughly 2003. And the big change that occurred with Groovy several years ago is it became an Apache project. So it wasn't originally an Apache project, but it was always open source from the beginning. And now it is a top-level project at Apache, though they retain the same URL, the groovylang.com one doesn't have an Apache on it. Pardon me. The thing I like about Groovy is that existing Java developers pick it up very rapidly because the syntax is very familiar to them. And then you start adding capabilities. Now, I loved Groovy was basically my first love, if you will. I mean, I was a Java developer first. But then when I learned Groovy, I just thought that was wonderful. And I'm kind of sad that the market share isn't bigger on that, but oh well. But I'll show you some features out of it. But the integration of Java and Groovy is so clean and so smooth that almost every Groovy success story is also a Java success story. You know, they combine them. I've never seen a project bigger than a toy one in Groovy that didn't have some Java in it anyway. I mean, at least with the libraries and maybe more. The current version, I think I might have upgraded to 4.0.6 or something like that, but it's Groovy 4. And the nice thing that occurred in Groovy 4 is that the Java Lambda syntax is now supported in Groovy. Groovy has their own approach to this. We'll see in a moment, called closures. But now they also support the Java Lambda syntax. It used to be if you wanted to use Java libraries that took a functional interface, a predicate or a supplier or something like that, you used a Groovy closure, and you still can. But now you can also use a Lambda. And one of the points of pride of Groovy developers is you could take Java code and rename the class to .groovy, and it probably compile with Groovy, even though it won't be idiomatic. You know, it probably work. The Grails framework is what first attracted me to it, but Spock is still a going concern. They just changed versions recently. Gradle, of course, likes to pretend they didn't come from the Groovy world, but they did. And I mean, they push Kotlin relentlessly now, you know. Jeb is a good one that does like browser automation, like Selenium. It's actually front end on, I guess you call that WebDriver now, more of that. The others aren't as active. Kotlin is the first language I'm familiar with that's actually managed by an IDE manufacturer. So that was an interesting choice. And Kotlin often feels like a bit of a Frankenstein monster in that you look at Kotlin and you could say, oh, this is Groovy, and this is Scala, and this is C#, and this is, you know, you can just see where they pulled parts from all over the development ecosystem and put them all together. And sometimes you could see where the stitches are, you know, but it works remarkably well. And of course, the biggest thing to happen to Kotlin was that Google decided to support it as the default definitive language for Android development. Now you can use Kotlin for anything. You can use it for anything that you can use Java for. And the Spring people, for example, are very fond of Kotlin. So they have they have their own extension libraries, and it's really kind of nice to use Spring with Kotlin together. Whether that will take off or not, I don't know. Now, the two things that drive people toward Kotlin, things that appeal to the developers as opposed to the managers, you know, that appeals to developers is that Kotlin enforces null safety at the compiler level. If you don't declare a variable can be null, when you declare it, it can never be null, and that'll be enforced at compile time. Also, if you declare it to be nullable and you try to invoke a property or method off of it, Kotlin will insist that you check that it's not null as well. So if you've ever been burned by null pointer exceptions, Kotlin looks suddenly very attractive. The other thing that people really like about Kotlin are the coroutines, the ability to do concurrency. And Java, of course, has Project Loom someday. You know, I know they put out the first preview edition in Java 19, and typically these things go through a minimum of 2 previews before they become released. And sometimes they go through 3 or 4 preview editions. I think you've got at least a year and maybe 2 before you have to worry about virtual threads in Project Loom being part of the Java ecosystem, because then, of course, everybody has to adopt that version of Java. So that's even longer. But you could use Kotlin coroutines immediately, and I do have an example I can show you of Kotlin coroutines, and they're very similar to virtual threads. They use the underlying threads and they share them, and they don't block the threads in general, just like virtual threads. And that is very appealing. To give you an idea, in the Android world, Android is an ecosystem where you're fundamentally faced with a user interface that you code. You know, and when we were all back-end developers writing websites, then our front end was HTML and CSS and JavaScript. And, you know, there are desktop Java people, and they don't like being overlooked, you know, small but vocal community. But other than that, you didn't think about doing your own thread management that often. I mean, you could, but you let the app server or the web server, you know, Tomcat handle the threading for you. You did have to worry about thread safety, but in spawning threads and things like that, that's not something we did a lot. With Android, it's critical that if you do anything time consuming, you have to get off the user interface thread. You can't lock up the UI when you are accessing a database or accessing the network. And therefore, they had to deal with threads all the time. And their approach for many years was reactive. They went with RX Android, which was an adaptation of RX Java for Android. As soon as they shifted to Kotlin, they had coroutines, and it's almost like RX vanished overnight. Like you rarely see anything reactive in Android anymore. It's all coroutines. And I was wondering if a similar thing would happen to Java once, say, Spring adopted Kotlin, and now you don't need to do reactive Spring, you can do coroutines. But it's much harder to displace Java in this world. And we'll see, I mean, I'm keeping an eye out, see how it goes. Anyway, those are the things that probably would appeal to you if you're a developer and looking at Kotlin. Okay, so Java, of course, has Lambda expressions. And rather than define a class or an interface called Lambda, they just reuse interfaces, specifically single abstract method interfaces. The parameter types are inferred from the context, so we get these Lambda parameters that don't seem to have types on them. You can access local variables, but you can't modify them. Now that's interesting, because as developers, one of the things that we're going to talk about a little bit later is the difference between a Lambda and a closure, which I have to warn you, wars have started over less, okay? But I'll let you know. I mean, I'll give you a definition anyway. And one of the interesting things about that is that with a closure, you have a function that can access and modify all variables in scope. It's closed over the execution environment. So whatever variables are around. And in Groovy, yes, you can modify variables in scope. In Kotlin, you can modify variables in scope. In Java, you can read them, but you can't modify them. They are final, or as they say, effectively final on those. And like most things in Java at this point, it's a compromise, but you'll get that with languages with literally 25 years of backward compatibility issues. Okay, Groovy has closures instead. They are instances of their own class called closure. This is actually part of how you make domain-specific languages too, Groovy closures. Very powerful that, like Gradle, for example, and in a closure, which is a block of code, the question becomes, if I'm going to access a method or a property, where is the runtime environment going to search for that property if they can't find it in scope? In those closures, they have a property called delegate. And a lot of creating a DSL, domain-specific language, is about setting the delegate to what you want, so that when they write, repositories, braces, Maven Central, it goes, oh, Maven Central must be in the delegate. Oh, I have to take this. Hey, Venkat.
Hey, how are you doing?
Oh, great. We're at the New York JavaSIG. You might remember them. They're the ones you spoke to a few months ago.
Yes, that's a fantastic group. How are y'all doing?
See, I'm not the only one who panders, right? Very good. Hey, I just have a question. How many Java users groups have you spoken at in the past few years? I mean, pandemic aside.
When I turned 50, I spoke in 52 Java user groups in that year.
Yeah, that's what I thought. Did you hear that? 52 Java users groups in the year he turned 50. Yeah, okay. What's your travel schedule like for the rest of the year? Just out of curiosity.
Oh, I'm in Atlanta Java user group next week, and that's it.
Okay, well, all right, dazzle me. What's January like?
I'm in 3 different cities.
That's all?
Yes, that's it.
You're letting me down. I mean, not really, but I mean.
January.
Yeah, you were gone for like 3 months, weren't you? Or something like that? You were all over the world?
I did 11-week trip.
11 trips or something like it. Isn't it true that when you board the plane, the pilot just hands you the keys?
No.
Okay. Well, okay. Why are you calling?
Well, since we chatted, so I thought I would give you a call and see how you're doing. So,
No. There's another reason I told you to say.
Well, first of all, I did the talk, so why are you there talking again? That's my question.
Well, I gotta fix the mess that you left when you just live coded the whole thing. I remember I gave you the slides, man. I gave you the GitHub repository. I mean, I expected you to do the speaker equivalent of presentation karaoke, and you know.
But you can ask anyone there, and they will tell you this. Half the talk, I spoke about how awesome you are.
Oh yeah.
And I did that really slowly. And the
Really
rest of the talk
slowly
is
so they get it. Yeah.
fast. They're still parsing it. So there's no mess at all.
Yeah. All right. Hey, Rodrigo, where's Rodrigo? Rodrigo walked out. Where is he? That's what we were trying to set up. We wanted to congratulate Rodrigo on being a Java champion. Remember, I told you to say that?
Yeah, where is he?
Yeah, he walked out of the room. I don't think it was anything I said. All right.
Well, it's great to have one more Java champion, and for him, this is very, very hard-earned, award. So, I think they should be extremely proud about. So I really wish he was there for us to say that in person.
Yeah, I mean, what's the point of saying all this stuff if he can't hear it? You know, I mean, at any rate, I'll give him your best. Is there anything else you wanted to say to the Java users, the JavaSIG here? Because there's a special interest group. They're not a Java user.
I love them all. Stay well, and enjoy the holidays, and look forward to seeing you all next year.
I mean, he says this because he's in Florida, right now. Yeah. Okay. Well, thanks a lot, man. I will talk to you soon.
All right. Cheers.
Take care. Bye-bye.
Thanks.
Okay, yeah, we did set that up. Okay, so anyway, and Rodrigo walked out of the room. Okay, we got to give him a really hard time when he comes back. All right, so anyway, back to Groovy here. Closures have a delegate property. And in fact, I was saying all this without showing an example. I don't have the delegate example handy, but what I do have is, it's in Kotlin. But at any rate, this is my Gradle build file. And you see, we'll wait for him to show up. At any rate, you see this repositories term. By the way, how's the font size on that? Can you see okay? Okay, so repositories is part of the Kotlin, or rather, either one, the Kotlin or the Groovy DSL. It's part of the domain-specific language. And of course, Maven Central is a method, or in Kotlin, you'd call it a function. But either way, how are you resolving that? How is the runtime environment resolving that? In Groovy, there would be a delegate for this closure, for that block. And the delegate is of type, I don't know if you can see that, repository handler. And of course, in Kotlin, they have something similar. They call it a Lambda with receiver. And that's the receiver, is the repository handler. So when they navigate to Maven Central, it's actually a method in repository handler. So this comes up whenever you're dealing with DSLs, for example, and just an interesting feature. And Java doesn't have this. And that's part of the reason why it's hard to write a DSL in Java. The Groovy is really good at this, and so is Kotlin, and Java's really not so much. Groovy also has something called a meta object property, object protocol, but I might get to that a little bit later. Okay, so in Groovy, you can access those variables and modify them. So it really is a closure. It's not just a Lambda. A Lambda, in a mathematical sense, is supposed to imply a pure function, a function where the output is the same for the same inputs, and there's no side effects. So like println, printline's not a pure function because you're actually modifying the output, but addition is a pure function. You put in 3 and 4, you always get 7. And lambdas aren't defined to be pure functions, but the implication is that you're supposed to aim for pure functions. That's the goal. Is a goal in functional programming. It's something you want to try to achieve. So at any rate, in Kotlin, we have our Lambda expressions, and they went a completely different way. Instead of making a class or an interface called Lambda or closure or what have you, they say the actual data type is parentheses with the input types, arrow output type. That's literally the data type. And if you look at the library in Kotlin, that's what you're going to see. Like when I think I had one open earlier, this Astro request. Let's see. No, that's great. I picked one that doesn't have any. Yeah. So the fold method here takes, let's see, I can magnify that. Oh, I can't do it while I can't do it at the same time I mouse over. The fold method in Kotlin takes two arguments, an initial value and an operation. And the argument, the second argument is parentheses R, the return type, comma int, arrow R. So it takes the result and an integer and returns an R. So that's the type of the Lambda. And that's a completely different approach than either Groovy or Java in how they do that. So you just have to get used to it, but it's still just the same concept. So they use what they call a receiver for resolving those properties and methods inside the Lambda. But they're really closures. You know, Bruce Eckel, the author of the Thinking in Java series, that was my first Java book, actually, back in the mid-90s, you know, when dinosaurs roamed the earth, you know. He wrote this very cynical blog post saying the difference between lambdas and closures is that most people think, oh, there he is. Now you're here. Venkat says hi. Yeah, you ruined it, you know. We had Venkat call in and then he was going to say congratulations. For at any rate, Rodrigo just showed up, you know. Well, as long as you're here, you might as well come up for a second because the user group has a gift for you for being a new Java champion. There you go.
Thank you.
Rodrigo.
Mine has to work though. Still there on the desk.
That's Rodrigo, isn't it? I mean,
Send you a member, so you know you're not.
That's why you became a Java champion.
yeah, sacrifice the glory in order to get the job done, man. I mean, I'm impressed. Okay. Yeah, you're forgiven. So anyway, but you'll have to take it up with Venkat. Okay. In Kotlin, actually, let me say it this way. Bruce Eckel was claiming that most people have this idea in their head of what a closure is based on the first language where they encountered them. And for most people, certainly years ago, that language was JavaScript. You had functions inside functions, and then they started talking about closures for all of that. And it's very difficult to figure out whether this variable is or what it's pointing to and all of that. And therefore, Java called them lambdas because they didn't want to conjure the same image. That's, yeah, I don't know if that has any valid, validation, that story, but I like the story anyway. Venkat called back. Hey, what's up?
Hey, let's wish the man.
Yeah, he's back. Yeah.
All right. Well, hey, go ahead and you start. I'll join.
Okay. Anyway, here's Rodrigo, and I'm holding this close to the mic. So say hi to Venkat.
How are you, Venkat?
Hey, congratulations.
Thank you very much.
Yeah, we gave him a little present and everything, believe it or not. Well, we didn't. I mean, the New York JavaSIG did.
This is amazing, and it's an amazing accomplishment, and your journey towards this is a remarkable one. A lot of things for a lot of us to learn from. So congratulations, and thank you so much for being such a wonderful role model for a lot of us.
Thank you. Appreciate your kind words. You know that you're a role model for many of us. So thank you very much.
Don't too much. He's going to get a swell head.
Okay.
Yeah. Okay. I mean, Venkat, you got to keep him down a little bit. It go a little overboard. Oh yeah, sorry, you're still here.
That's what friends do. Awesome, man.
How's your conference going? Is it going well?
Congratulations.
Okay. Okay. I told him congratulations. Thank you very much, and we'll talk later.
Thank you. Bye-bye.
Take care, man. He called back just to get you. That's Venkat. Yep. If he wasn't such an incredibly nice person, he'd be so annoying. I mean, oh my goodness, I mean, it's not only that he speaks everywhere, he's got a book on everything. right? I mean, he finished 2 books in the time it took me to write that Makito book. I'm so annoyed, you know. We learn on the No Fluff Just Stuff conference tour, you do not compare yourself to Venkat on any scale whatsoever except height. Yeah. At any rate, I mean, I love the guy, but it's a good thing because otherwise I'd hate the guy, you know. All right, let's move on. Let me show you well, actually, I'm going to skip the simple examples. I have some in the actual slides here and then move to the more advanced stuff for this group. So I do have several, and I tried to do this. I tried to identify the classes in the GitHub repository. So when you look in the GitHub repository, you can go find the examples right away. And what I want to show you, actually, let's just skip to this. Oh, I'm not showing it. No, I guess I have to show one anyway. So here's the GitHub repository. And the first one, of course, is my Lambda demo. And of course, then I'm using for each which takes a consumer here. So it takes a single argument, and this is written as a block Lambda, but of course I can use a simpler, you know, just a single, actually, I don't know why I didn't do it here. Let me just change that to a, oh, it doesn't even want to do it anymore. Maybe if I put the cursor on the other side. Yeah, there we go. No, it really didn't want to change it to an expression Lambda. At any rate, I can take, well, I have it commented out, so it shouldn't matter, you know. But, oh, I might have that. No, I see, I commented that out too. At any rate, it can convert to that or a method reference, but you've seen the Java one many times. So let me bring up one of the Groovy ones. Now, the Groovy thing, the names of the methods are unfortunate, and they were chosen before Java got involved. And therefore, we're stuck with a couple of awkward names. Like they actually use the word collect to mean map. And that's too bad. Because, of course, Java has a collect method, and we're used to it by now. It converts a string back into a collection. But that was long after. You know, I'm sure if Groovy had to do over, they call it map. Find all is actually a better name than filter. I mean, I can't tell you how many people I've talked to who use a filter method and say, but a filter should remove things, not say, oh, if you pass the predicate, you go through. It should be like, no, filter out. Yes, hi, Gene. Find all in what? GREP? I wasn't that sure Groovy had a grep method. Really? Is it used for things other than strings? I mean, like with regular expressions? Well, grep naturally is a pattern matching mechanism. So I assume it's based on that, but I've only used find all. Isn't that interesting? Okay, hey, I learned something. I'll have to look. This is how I'd find out real quick, by the way, is just go to groovylang.org and go to the documentation and, pardon me? Oh, I've got that for other things. Yeah. I've got, oh, all right. Well, actually, now that you bring it up, there, I loaded it. The problem is they are having issues with volume. What's the difference between grep and find all? In Groovy, the grep method is used to filter a list of objects based on a given regular expression. The method returns a list of objects that match the given regular expression. The find all, on the other hand, is used to filter a list of objects based on a given closure. This method returns a list of objects that satisfy the criteria specified by the closure, and they put in words and, oh yeah, it is. It's using a regex. Yeah, because, well, the question becomes, do you believe this or not? You know what I mean? It's like, oh yeah, I mean, it goes on and on. Let me ask it something a little bit harder. Who is Frank Greco? Yeah, okay. Find all applies the closure. It's like using a predicate in a filter method in Java. It's exactly the same. Okay.
Thank you.
Oh, they don't know anything about Frank? Wait a minute. Okay. Who is Venkat Subramaniam? Come on, you can do it. Huh, okay. You know what? When I did this before, it knew who Venkat was. Yeah. I don't know what happened here. Try again. You know? I mean, I was doing this the other day, you know, doing a little experiments with this thing. Wow. Boy, that's disappointing. Okay. Let's try something unrelated. Tell me a light bulb joke about functional programming. I wonder, you know. You mean about this one? Why did the functional programmer refuse to change the light bulb? Because they declared it a constant and constants cannot be changed. Okay, humor is subjective, I suppose. The last answer I got was something about how many programmers does it take to change a light bulb? None. They apply a transformation to the room, a lighting transformation to the room. And I thought, okay, that's actually not bad. You know, I can live with that one, you know. Okay, we'll come back to this. You know, and by the way, I copied and pasted, I saved some that were good answers from before. Like, I'm pretty sure in my little file here, where's the one about Venkat? Oh, okay. I'll come back to those because I must not have saved that particular answer. Because of course it gave a whole list of books and everything, you know, Venkat, you know. Any rate, we'll come back to that. So just to show, the final thing is that every language that does functional programming has some kind of reduction operation. Okay, so in Java, it's called reduce, and it's overloaded to take a binary operator with the initial value or the identity value, really, and then actually a lambda with the binary operator comes second. So the identity value and the binary operator, or just the binary operator. In Groovy, the method is called inject of all things, which makes sense if you're thinking of it in terms of an accumulator. You know, that works. In Kotlin, they call it both reduce and fold. So the 2-argument one is called fold and the 1-argument one is called reduce. I have no idea why. At any rate, so just to give you that quick example here, the what did I call it? I just forgot. Map filter reduce. Let's do so you can see the braces here surround the lambda. So it's different syntax from Java. There's still an arrow here like this one. This is the 2-argument inject here. See, there's the identity value for the accumulator. And then this is a lambda that returns whatever the last expression is, becomes the new value of the accumulator on the next iteration. And all of the reduce operations in all 3 languages work the same. They just have different names. So you just have to get used to the differences in syntax. Of course, Groovy gives you a sum method, and you don't even have to verify that you're dealing with integers, or, you know, actually any class that has a sum method in it will work in this. So it could be string concatenation. It could be, well, whatever you define the sum method to be. The other thing about both Kotlin and Groovy is that if you have a single argument to a lambda, and that argument doesn't have an explicit name, the name becomes the word it. Now, this is another one of those stitches things. In Groovy, the person who came up with the language spoke English. So yes, print it. That made sense. That was perfectly natural. The people who came up with Kotlin spoke Russian. I don't know what the Russian word for it is, but it's not it. But they used it anyway because they grabbed it from Groovy, basically. I mean, yes. Is there another comment, Gene? Or, oh, okay. I thought you were asking something else. Yeah, I mean, again, like another case, Java has a ternary operator, right? Boolean expression, question mark, value, colon, value. Kotlin doesn't have one because an if statement in Kotlin returns an answer. So they don't need a ternary operator. The if statement's already a ternary operator. But they have an Elvis operator, like Groovy does, question mark, colon. Question mark, colon came about in Groovy on the cases where the value of the Boolean was true, and we're just going to reuse it again. And in Groovy, define the Groovy truth to say, oh, X, Elvis 0 means if X is not null, just use it, otherwise use 0. But Groovy has a ternary operator. Kotlin doesn't, and yet they have an Elvis operator. Yes, sir. In Java, we have filter, and Groovy, we have find all. Yes. They have find first and find any. Right. So find first returns, yeah, they don't have the find all is filter. But yeah, find first returns the first element to make it to that point, but it's consistent because it always works from the left end, you know, the first sequentially. Whereas find any will return any value that gets there first, and that only comes up when you're operating in parallel. So for what it's worth.
Chain 3 find alls will create 3 intermediate collections. In Java, filter will create nothing. But you can change 3 filters, it will still just 3. It will not be terminated.
I'm going to have to check that because the comment that find, yeah, I know, I can't repeat that whole thing. Sorry. Yeah, the comment is that find all can return a collection. I know find all is a terminal operation, so you can't chain find alls. So I'm not sure how you do multiple find alls. Oh, so you're saying, well, no, find all is on stream. It's not on collection. Oh, in Groovy. Yeah. I'm sorry. Yeah. In Groovy, you could have multiple find alls. Yes, that's right. It'll create multiple collections. So it's not an efficient way to do it, but it will work. Yeah. Okay. Thank you. And boy, it's good to see some Groovy knowledge in here. At any rate, all right, we get the idea. So let's go on. One of the neat things about Kotlin, by the way, is they have something called single expression implementations. If your function is implemented with a lambda that has only a single statement in it, okay, then you can rewrite the lambda in this form. You can remove the braces and just use an equal sign after the signature and assign it to whatever the return value is. And then once you've done that, it will infer the data type of the return value, and therefore we can get rid of the return type as well. Also notice in Kotlin, the data type goes after the variable and the return type on a function goes after the signature. So this I like to refer to as speaking Kotlin with a Java accent. You know, I mean, that's a Java developer who's just writing in Kotlin. This would be much more idiomatic. Now, you don't have to do this, but if you browse the library, which is a good way to learn how the people who write Kotlin wrote Kotlin, you know, they really go a long way to try to use this mechanism a lot. And they've also added things like scope functions, like also and apply and let, that make this come up a lot. That's like saying the dot let is like, once you've got a value, then let's do this, and you just put a lambda there. And you could even do an assignment because now it's all one big statement with the lambda. Another thing that happens, by the way, and I should have mentioned it in the primes one, is that in both Groovy and in Kotlin, if you have a lambda argument, you put it last. The reason you put it last is because then it can go outside the parentheses. And if there are no other arguments, you could drop the parentheses entirely. This also makes it much easier to write DSLs, to write domain-specific languages. In Groovy, you could put the Lambda or the closure inside the parens or outside, doesn't matter. In Kotlin, if you put that Lambda inside the parens, IntelliJ will complain about it. They'll say, that's not idiomatic. I want to move it outside. You go, okay, and moves it outside. And then if all you have are empty parentheses after that, it'll say, you want me to remove the redundant parentheses? Like, fine, you know. So at any rate, interesting. Now, Java made another decision here that Groovy and Kotlin approached a little differently. Java did not add methods like filter and map and reduce to collections. They could have, Groovy did. Instead, they introduced a layer of indirection, right? All problems of computer science are solved by adding a layer of indirection, you know, something between me and where I want to go. That layer of indirection in Java is called streams. So the methods are added to streams, and the benefit of using streams separately is it's a different abstraction. Streams are lazy. You can have a whole series of intermediate operations. If you don't have a terminal operation, nothing happens. That was, I had a stream joke in there. It was like, how many stream coders does it take to change a light bulb? Well, only one, but if they don't add a terminal operation, the room stays dark, you know. So at any rate, unfortunately, that one's mine. So to blame me for that one. At any rate, Groovy added the methods directly to collections, which makes them eager. They don't necessarily short circuit. They can apply to every individual value. So you say, well, what if I wanted them to behave like streams? And the answer is, well, use streams. Because you could just say dot stream and just use all the stream methods. They're still there. Just because you're using Java syntax doesn't mean they aren't available. You know, in Groovy, you can just use Java libraries directly. So there's no need to reinvent the flat tire, which is what happens when you reinvent the wheel and get it wrong, you know. Kotlin, on the other hand, had to reinvent it. And what they did is they made sequences in Kotlin. You have to say on your collection .as sequence and then throw in the rest of the methods. And then they operate the exact way streams do. They go element by element through the entire pipeline. If you don't have a terminal operation, nothing happens, etc. The Kotlin documentation has a really nice illustration of it. Okay. Oh, I did have the code in here. So there's a Java filter, map, and reduce, or just Java. The other thing Java did is they threw in a map to int. Might want to adjust that. Okay, map to int is a consequence of Java's strong typing. The idea is that instead of producing a stream, that'll produce an int stream. And there is int, long, and double stream. And int, long, and double stream have sum methods, a method called sum. So if you produce an int stream, like take the numbers from the collection and filter, just find the ones divisible by 3, and then I want to double them and add them up. Well, I could do a sum method if I use map to int, whereas here map would produce a regular stream. I'm stuck using a reduce with an accumulator if I want to do that. In Groovy, I could just call collect with it times 2, and Groovy has operator overloading. So as long as the whatever the class is has a multiply method and a modulus method, then this will all work. And it's just fine. And here I'm just writing .sum and just trusting that there is a sum operation involved here. Now, of course, if there isn't, I'm going to get an error, but that's what tests are for, right? Check that. In Kotlin, there's a fold which has the first argument and then the lambda, and I'd reduce or reduce if there wasn't the first argument. Now, the first argument is supposed to be the identity value for the accumulator, but it's also the initial value of the accumulator. So this is going to start the accumulator at 0, and then this is going to add them up starting from 0. Each element through the nums will be applied to this after making the map and everything. Okay. Yeah, and then this is the only difference. Just throw in a .as sequence, and we're good. Now, let me skip the pojos and pogos. I think we're good on that. Okay. Another example of a substitute coming in Yeah. Drew Bledsoe was a quarterback for the New England Patriots for many years and had just gotten a huge contract. And he wasn't doing so well the subsequent year, but they still look like a strong team. And according to the Wikipedia page, following a period of declining success and 2 consecutive seasons in which the Patriots missed the playoffs, Bledsoe suffered a near fatal injury early in the 2001 season that led to backup Tom Brady becoming the team's starter. And that was all she wrote. I mean, Bledsoe came back in for 1 game in the playoffs when Brady had an injury, and then Brady took over again. And, Brady's still playing for Tampa, but he's playing. And, again, I feel like I'm not the Tom Brady in this scenario. I'm the Drew Bledsoe in this scenario. This is not good, But there's another classic example. Are you sure you want to go out? I mean, I almost died, so I guess he didn't have much choice, but okay. All right, now let's go beyond the basic map, filter, reduce stuff that Java can do. Java is very limited in its functional capabilities. So let me mention closure composition, and then a little bit about memoization and tail recursion, and a little bit about currying. So Java doesn't really have closure composition, but they do have some methods in the library that behave that way. For example, if you were to look in, here's the Java documentation for, I guess I'm on 18 at the moment, but it doesn't matter. Here is predicate. How's that font size? Is that big enough? Okay. So you see in the predicate, we have an AND method that takes a predicate and returns a new predicate, and we have OR and we have NOT. This is function composition. It's a higher order function. It's a function that takes a function as an argument and returns a new one. So the problem with this is that if you look at the functions in a library, predicates can only be combined with predicates, consumers with consumers, functions with functions, and that's it. You'd like to say, oh, the output of this function then becomes the input of this consumer. You'd like to put those together. Now, I'm not saying you can't write it yourself. In principle, you could, but there's nothing built in to Java to do that. And if you're not aware that that's even a thing, it won't even occur to you to write it, Whereas Groovy, on the other hand, has an operator specifically for composition. So if I bring that up, see, here is a closure. Make that a little bit bigger. That adds 3 to whatever the argument is. And you can assign that to a variable. And here's a closure that multiplies by 2. And then I could use the left shift operator or also a right shift. But here I use the left shift operator. And what the left shift operator means is add 3 and then multiply by 2. So when I add 3 to 5, whoops, I did it backwards, right? Multiply by 2, make it 10, and then add 3 gives me 13. So this is closure composition. The ability to take whatever the output is of the first closure and make it the input of the next one. And they actually have an operator for it. So closure composition, or more properly, I suppose you'd call it functional composition in the mathematical world, is a thing in Groovy, and you could use it. And the only thing here I had to do is put it in parentheses to make sure that that happened before I applied the argument to it. And that's really nice. So here it is in one order, here it is in the other order, and you see that the answers, of course, are different. Whether I multiply first and then add, or add first and then multiply, I get a difference on that. So that's built right into Groovy. Java doesn't have anything like that. And ironically, neither does Kotlin. Looking at Kotlin, this is an example that I borrowed from the Kotlin reference manual. And you see what they did is they declared a compose function. Every function in Kotlin has to have the fun keyword on it. I promise not to make any jokes about that. So A, B, and C are generic types, and F is a lambda that maps B to C, and G is a lambda that maps A to B, and the return type is a lambda that maps from A to C, which just goes take whatever the argument is X and apply F of G of X. So if my first function here is to get the length of some string, and my second function is to find the odd numbers, check if something's odd or not, because that's a Boolean expression. Then here I can compose. There's actually this method that I wrote up here, compose, is odd with length. The is odd with length, and these are the strings with odd lengths. We get the length and then we see if they're odd. And it works, and I can do a filter, and then also that's one of those scope functions which lets me just print the result. I mean, you apply a consumer basically to also. Now, the really funny looking method reference here, without anything to the left, is because these functions are right here, what they call top level functions in this script. Yes, sir. Yeah, it's Kotlin like with in Groovy, is also like with in Groovy. One of the scope functions is exactly like with in Groovy, but it's not also. It's the difference. I'm trying to think of what the return type is. You know what I mean? Because with in Groovy, you apply to an object, and that way you could reference the properties directly, and you get the object back. That's apply. That's apply in Kotlin. Yeah. So yeah, same idea exactly, just different scope function. Yes, sir. Yeah, the question basically is the way you could get around this in Java is do things in a stream, because then you could apply a filter and a map and a supplier, whatever. I mean, well, start with a supplier, I guess. But anyway, you could apply things on the stream, and then the question is that basically the problem with that is it's not reusable, not directly. When you look at function composition in actual functional languages, the way they tend to write is they build up a library of functions and then just wire them together like Unix, like the Unix operating system does. Yeah, the output of this becomes the input of that and transform, etc. So yeah, streams are a workaround, and I don't know if it's the reuse, but yeah, it's basically sounds like very similar. Yeah. Yeah, I mean, it is hard to reuse stream code. What I notice people do, though, is to take the lambdas, the predicates and the consumers and everything, and make those attributes of the class. So then, okay, yeah, it's a filter, but it's this filter, and I'll just grab it. But you still do have to write the stream and the filter. Yeah, there's no way around that in Java, right? Very good, yeah. Any rate, so that's different. Now, tail recursive. This is another interesting one. The idea of tail recursion is that you have a function whose last expression in the function is to return a value that becomes an argument of the recursive call that comes back again. Now, I want to show you this. In Groovy, they solve that problem in what I consider to be a really good way by using these things called abstract syntax tree transformations, because you don't have to modify the language to write an AST transformation. In Kotlin, they made a keyword. That's modifying the language. That's a much bigger decision there. So to see an example of that, let me look at my annotated functions here. So actually, since I opened it to memoize, let me show you memoize first. The beauty of memoize is that it creates a cache of output values based on the input values. So this is a Fibonacci calculation. Fibonacci numbers are the sum of the previous two, on any integer. So when I put in a big integer n, then if n is 0, just return 0. If n is 1, return 1. Else it's Fibonacci of n minus 1 plus Fibonacci of n minus 2. And in a code review, people would immediately go, that is horrifically inefficient. That's almost guaranteed to lead to a Stack Overflow problem because there's so much repeated work between, if I did fib of 8, it's fib of 8 is fib of 7 plus fib of 6, and fib of 7 is fib of 6 plus fib of 5, and we've already got a repetition, and the number of repetitions grows exponentially, depending on how big it is. So you can only do fib up to, 40, 50, 60, before you run out of memory. This changes everything. You have to apply it to a pure function, a function that always returns the same output given the same input, because what it does is defines a cache. And when it calculates fib of 1 or fib of 0, that goes in the cache. And then when it calculates fib of 2, that goes in the cache. And therefore, as long as I put memoized on this, I can run that fib calculation into the thousands without running out of memory, because all the previous values are in the cache. In other words, it's basically treating it like it's iterative rather than recursive on that. And if you look at the docs on it, it says, creates a cache for the results of the execution of the annotated method. Whenever the method's called, the mapping between parameters and the return value is preserved in a cache, making subsequent calls with the same arguments fast. And here's a factorial one too. Oh, wait, really bad Fibonacci joke. This year's Fibonacci conference is supposed to be better than the last two combined. But I'm pumped. Yeah, I know. But I couldn't do a fib calculation without breaking that up. This one, again, is a factorial one. Again, expressed as a recursive pure function so that I could throw a memoized on there and it would work. This is the demo. If I was to run it, I put a sleep in here so that the first time this does the addition, you wait a second. And the second time it's instantaneous because with the same two numbers, because it's in the cache. That's the idea. And normally we'd have to write the cache code ourselves, make it cacheable and implement all that. We don't have to do that with the AST transform. It does it for us. AST transforms in Groovy are compile time modifications of the abstract syntax tree to produce whatever the person who wrote the transform wanted it to do. And there's always, every release of Groovy has new ones, and there's a lot of really nice ones. Here's a tail recursive. The idea here is, here's my factorial function. This guy is the number I want to do factorial on. This is the accumulator. So it takes two arguments. And this is another nice feature of both Groovy and Kotlin, which is that you can put in default arguments. So I can run factorial of 100. I don't have to put in the second argument. The second argument will be 1, and G means big decimal. So this will just say, hey, is n less than 2? Then return the accumulator, otherwise called factorial of, and this is n minus 1. And then here is n times the accumulator as the second argument. So I've already made it iterative. Now, the thing is, if you ignore the default here, I could write that in Java, right? No reason I couldn't. What the tail recursive annotation is doing is making it, I'll just say it, so that it's reusing the stack frames over and over again. If you write that in Java, if you write a tail recursive function without saying anything beyond that, it's still a recursive call. It's still going to use all those stack frames. So it's not going to be that helpful. Yes. I don't even need to repeat the question because, should I repeat the question? I mean, basically the question is coming down to, is memoized implemented similar to the way aspect-oriented programming would be done in Java, right? And that's actually a really good analogy because AST transforms are invoked at compile time. Just like AOT with aspect or AOP rather, with AOP, you write a class that is compiled, and then you intercept method calls and apply the aspect, if you will. You advise methods and everything like that. It would be a very specialized AOT transform. I mean, because you'd have to write it for this specific purpose. But yeah, a classic example of an aspect-oriented programming of an aspect is a cache, isn't it? That you would actually make a cache that way. So yeah, the more I think about it, the more I think, yeah, that really is something you could do in Spring pretty easily, because Spring makes it easy to write aspects. Yeah, that's really a good analogy. Thank you. Yeah. The difference in Groovy between memoize and its other, what do you call metaprogramming capability, is metaprogramming is done at runtime. And a lot of people get suspicious of that. They call that monkey patching or whatever. They get nervous about that. But memoize and AST transform is done at compile time, and therefore it's tested and whatever, what have you. I don't know that I get so worked up about it. I think, runtime metaprogramming is fine in small doses, but okay. But yeah, I never thought about thinking of it in terms of aspect-oriented programming, and that's a really good analogy. Any rate, the tail recursion, as I say, if I wrote this in Java, it would still build up the stack. It wouldn't reuse the stack frames. It wouldn't transform our recursion into the equivalent of iteration, and therefore get the benefit. In Groovy, you apply tail recursive, and it says, yeah, because the JVM cannot do this itself. So yeah, so they wrote it that way. Yeah, okay, there's a value judgment. All right, I get that. Okay, they have one. This one is from the documentation where they do a greatest common denominator calculation with integers. Here's a sum with big decimals, size of a list. At any rate, I have a test for all this that use Spock tests. So there's factorial with tail recursion. Of course, I didn't go really high on that. But there was one where I did, yeah, this one, size of list, the range from 1 to 10,000 should be 10,000. Here I'm summing up all the numbers up to 1 million, You can do that. Yeah, I thought I had better illustrations of really big numbers, but you get the idea there. Oh, I think it was in my use annotated functions. Yeah, I did a factorial of 70,000. And of course, I don't want to print that, it'd be huge, but I can see how many digits it has, something like that. And that works. So like if I just ran the main method here, it would run through it. And I think the factorial of 70,000 has a few 100,000 digits, I think it was. So yeah, 308,760 digits on that. And again, the reason it works is because it transformed recursion into iteration by using this tail recursive annotation. Okay. Now, that's about as far as Kotlin goes. Kotlin, again, doesn't have the composition, doesn't have currying or anything. But it does have libraries, and the number one library for doing functional programming in Kotlin is this library called Arrow. And Arrow would take us to the next level where we'd start talking about monads and monoids and all that nonsense. Oh, I suppose I should ask. Is a monad actually just a monoid in the category of endo functions? I'll put my question mark on there, right? Endo functors. Did I say it wrong? In some ways, yes, a monad can be thought of as a monoid in the category of endo. I should have said functors. A monoid is a mathematical structure that consists of a set of elements and a binary operation that combines those elements in a way that follows certain rules, right? A monad, on the other hand, is a type of abstract data type that allows for the composition of functions in a way that follows certain rules. Oh yeah, that's helpful. Well, you know what they say, right? If you understand what monads are, you lose the ability to explain them. Yeah. Okay. Yeah. Okay. Well, it's worth a try, I guess. All right. Oh, I didn't do the currying one as well. So let me show you currying here. This is IntelliJ IDEA. It's with the new UI. In fact, you can see here is, I think it's under appearance and behavior, is new UI, new user interface. So I turn that on. I'm getting used to it. Seems you don't like it? Oh, the theme I'm using is the high contrast theme. That's probably what you're reacting to. Yeah, I like the high contrast because it's easy to, it projects well. You know what I mean? So it's very easy to read from a distance and on a screen. And so I've gotten used to it. But of course, there's tons of themes, you know, and if you like dark, you look better. They still have dark and just regular themes, you know, but I threw that in. Now, currying is fascinating because the idea is I have this Lambda here, closure in Groovy. I want to produce a new function by replacing one of the closure arguments with something else. Now that something else could be a closure, that would get complicated. Here I've used the curry method to put a number in where X is here. This is an L curry in some languages, as opposed to an R curry. They also have an N curry in Groovy where you can pick the argument, but that gets complicated. At any rate, this now makes a closure called add3, and now it just takes one argument where the first one's been set. Now, again, it wouldn't be that difficult to write that in Java, you know, to actually do the currying. But in Groovy, again, they have a function, a method built in to do it. It takes an object and returns a closure, which binds to the first argument. And I didn't do an L curry or an R curry or an N curry or whatever like that. I did try this, not this way. Does functional programming currying, let's say this way. Does curry in Groovy have anything to do with Steph Curry? No. The term curry in the context of Groovy does not have anything to do with the basketball player Steph Curry. In Groovy, the term curry refers to a language feature that allows for partial application of functions. That means the function can be called with fewer arguments than it expects, and a new function will be returned. It takes, you know, in contrast, Steph Curry hits three-pointer. Yeah, see, that would be the next question. But, you know, could Haskell Curry hit three-pointers? You know, but I've already pushed it too far. You get the idea. Steph Curry's my favorite player from all time ever. You know, I love Steph Curry. So at any rate, whenever I think about doing closure currying, I wonder how Steph would do it. Okay. Yeah, I did put in the link about a monad is a monoid in the category of endofunctors, but I've already done that gag, so I'm going to move on. You know, Java has great difficulty doing monads, and the real problem is there's no way to enforce non-nullability. That there are annotations like not null, but they're not standard. They're not part of the language. And like even with Java's optionals, you're never supposed to return a null if you're returning an optional. I mean, an optional should never be null, but there's no way to enforce that. There's no way to guarantee it. And that throws off, you know, all that higher order functional stuff. It just can't do it. Now, I read a presentation by, I think it was Mario Fusco, who's good at this stuff, called Monadic Java. So he created it somehow, but it's not really realistic. Whereas Kotlin, of course, has nullability that you can enforce, you know, that non-nullability. And I would think you'd be able to do it there. Groovy might have the same problem with that as Java. I'm not sure. But again, Kotlin already has the arrow library that has certain monads already defined, you know, like the either monad and stuff like that. Oh yeah, one more example of a person who went out and was replaced. I mean, I realized we were in Times Square just about, you know. So Carlotta, I didn't even know her last name until I looked at the Wikipedia page for the Phantom of the Opera. You know, she was singing in the Paris Opera House in 1881, And of course, the phantom does something weird and she starts croaking somehow. And in comes Christine Daae, the chorus girl who can sing, has been well trained by the phantom, You're getting the reference, right? I mean, you get the joke here. At any rate, so she came out of the chorus and became a star. But don't watch the sequel, if you can avoid it. I mean, it's okay. It's got its issues, but it's mixed, All right, that didn't get as many laughs as I was hoping for. Yeah. The real life example that people talk about is Shirley MacLaine was the one who stepped in for, I think it was Pajama Game or something, that the lead went out and they brought her out of the chorus and she became a star right from that. But I don't know what happened to the woman who came out. See, that's the problem. I'm Wally Pip in this scenario. I'm not the star, Anyway, okay. A couple of metaprogramming examples, and then because it's kind of required, I'll do cat pictures and then we'll be all set. Okay. I mean, hey, it's got to have cat pictures. This is the kind of runtime metaprogramming you could do with Groovy. So here is my pirate example. So every class in Groovy, including ones from the Java library, have a meta class. And the meta class has a method on it called invoke method, an invoke method. Makes it really hard to talk about it, So what you do to do metaprogramming is you are going through the meta class to say, look, if I invoke the pirate method on a string, see, there's the string class, and I assign this to a closure, which is what I'm doing here. That's a closure. Then all strings will have a pirate method on them. And I use the closure without, see anything in front of the arrow? That's a closure of 0 arguments because the default is to have 1 argument. So the way you use it is like down here, just invoke pirate on hello world. So I'm using this, RESTful web service at api.fundtranslations.com. And I had to give it my API key and URL and code the delegate, that's the string that I'm passing in, and create my URL. This is part of the charm of Groovy, is that they took the Java standard library and added a ton of methods to it using this metaprogramming mechanism. Like they have a toURL method to convert strings to URLs. And then they have a JSON slurper class. Funny how Java still doesn't have a built-in JSON library. I think they are still gun shy because of what happened with XML. They wound up putting in an XML parser and then they were like, it's always out of date and we can never update it and all that, I don't know that that's it. I just wonder. Anyway, Groovy has a JSON slurper, and, here's my example. So let me run this one. Yeah. Ahoy world, how be ye today? Please fill out your session evals. I'd like to add ye to my professional network on LinkedIn. Yeah, I needed some strings to invoke it on. So this is the kind of metaprogramming you can do in Groovy. You could add methods and properties to existing classes that you don't have access to the source code, and that can be really convenient. Like in times I've used actual examples where I was dealing with, what was I dealing with? Complex numbers, which come up all over the place in mathematics. And the Apache Commons Math Library has a complex class. And they have methods like add and subtract, but Groovy has a plus operator that calls the plus method, not the add method, it's the plus method. So I realized with a little bit of metaprogramming, I could add a plus method and a minus method and whatever the appropriate overloaded methods are in Groovy to the complex class, and then just use plus, minus, and times and everything. A little bit of metaprogramming that vastly simplifies what you're doing. I like that. I don't see that as a bad thing. Now, Kotlin has lambdas with receivers, and again, everything's strongly typed. That's compile time, though. It works, and in fact, I had Venkat on the phone. He's got a whole book on that, on making DSLs with Kotlin. Of course he does. He has a book on everything, you know. But I didn't get into that. But I did use an extension function in Kotlin. For example, here is primes. Oh, I have to do a file, don't I? So here is an extension function. Is that big enough? Can you see that okay? Yeah. So the class name goes first. So this is a function that's going to be added to the int class. It's called isPrime. And I wrote it as a one-liner where I say, if this is 2, well, then it's prime. And then here, this is 2, the little less than or equals are, that's a IntelliJ hint. That's not in the source code. This is a range from 2.2. And here's one of the challenges with Kotlin. This is an int. See, that's the actual integer I'm invoking isPrime on. And you would think I could just run it through the square root function, which is a top level function that I can import. See, I don't have to think of it like a Java static import, but you don't have to do import static of math. You could just say import the function. Boy, that takes some getting used to too, I got to say though. At any rate, square root function takes as an argument a double. Well, in Groovy or even in Java, I just put in an int and it would promote it to double. We'd be fine. In Kotlin, no, you can't do that. That's a double. But then again, it makes sense if you realize that in Kotlin, they don't have primitives, they have classes. So it's not actually a lowercase int, it's a capital I integer. And you can't assign an integer reference to a double reference in Java either. You got to convert it. So they have the toDouble method. Now I can take the square root, I could round it up, I can convert it back to an int for my range, and then for every one of these numbers, I'll take the int and do modulo that number and see if it's 0 or not. I'm going up to the square root plus 1, basically rounded up. And this will, the none method is, Java streams have, it's any, and well, it's not called any, it's called, actually, it might be called any. What's it called? I blanked on it right here. I've got it though. Yeah. Can Kotlin square root be overloaded? Well, in principle, yes, but they didn't. They already I'm just importing the function. Oops, did I go to the wrong thing? 1 second. Yeah, I went to the package. I meant to go to the class. All right, could I write my own version of oh yeah, that's any match and all match. Yeah, the question is why didn't they just overload the function and make it numerical, and they could have. And I think the reason they didn't is because instead they added the conversion functions to double, to integer, to float, to whatever, already to the primitives or to the wrapper classes, So I think they could have definitely gone, that's the way Java would have gone, right? I mean, Java definitely would have made 10 different overloads for all the different primitive types and, yeah, but they didn't happen to do that here. Yeah. Anyway, I was thinking of all match and any match and none match in Java streams. In Kotlin over here, it's the none function and any and all. So this is an isPrime. And to look at the test, oh, I have a test. Say it again, please. All right, well, I'm gonna then the only thing I'm gonna show is the cat pictures, and then I'll be all set, and we can do that. But anyway, you see how these are invoking an isPrime method on all those integers, and this is a JUnit 5 parameterized test, just to run all the values through it, which works just fine. Okay, so let's leave that alone. Here's the cat pictures. Now let me tell you what's going on in this. This is a RESTful web service from Flickr. Remember Flickr? Yeah, I mean, it's still around, believe it or not. We'll see if it works. The idea is that, you call the Flickr photos search and it returns JSON or XML. And you, inside the JSON or XML, you can synthesize the URL of the actual cat picture. So I have this in two different ways. I mentioned it here, but I should at least also mention that I have this, this Kotlin one here that's using the retrofit library to access them. But down here, this is a suspend function with a bunch of coroutines, so I can get back all of them simultaneously, okay? But I don't want to run that. I'll do the Groovy one. So here is, here's the cat pictures. So there's my endpoint. These are the parameters I want to put together. They're in a Groovy map, including my key, which is inside the file here. This is a, well, collect, but it's really a map, putting all those entries together, joining them with an ampersand. I'll show you the URL. This grabs the JSON data, writes it to a file, and then parses it. And then when you drill into it, there's a photos element, and then there's 6 photo elements inside of it. So here I have a method to convert the photo into an image. And this is using a Java, well, this is actually an interpolated string to create the right URL for the individual images. And it would take that photo and make this string and convert it. And then image.io class from Java has a read method to read that and return an image. And this, oh, here, I took the photos and I'm doing that in a Java parallel stream. Convert them all in parallel. That's why I'm printing out the thread here. So you can see they're being done in parallel. And then this is a Groovy builder to build a swing UI. So there's a frame, visible, pack, and make a grid layout and exit on close. And for each image, let's make a J label that has the image in it. Now, I got to warn you, I don't know what pictures I'm going to get back. If they're totally inappropriate, I'll close it, okay? But I'm searching on the word kitties, and that tends to be pretty reliable, you know? I mean, kitties here, you never know, but I'm just warning you. It is, and that's a little troubling. Yeah, anyway, cat, I don't know, do you see a cat? I see a cat here, cat. I'm still putting that in a win column, okay? I'm trying to get off the EDT, get off the event dispatch thread, but I'm not sure if I'm doing it right. You know, I have to figure out a better way here, but you can see this is using all these different threads to access it. Whereas in the Kotlin one, I just don't build the UI. You know, I don't have a library for that. So there's your cat pictures, and that combined parallel streams with map and filter and parsing JSON and Groovy interpolation and everything. Okay, as a reminder, there's the GitHub repository. The link for all the code is in there, and I'll just push that to that. You use each language for what it does well, and Java is kind of limited, but does have a lot of stuff. Groovy goes beyond them, has more than any of the others. Kotlin has its own quirks, you know. There was a question there, yes.
Actually, I think we're out of time, and we have to exit the room in like 5 minutes.
Really? We have to exit? Well, what is it, a quick question? Do I have examples where of each language calling the other two? I didn't specifically organize them that way. I do have Groovy tests on Java code and on Kotlin code and Java tests on Groovy. I'm not sure I have all the combinations. Okay, but it's not difficult and they all compile together. Okay. Yeah. Okay. Well, thank you very much. I'm sorry to get the internet question. Yeah, sorry about the internet questions. If there's okay. Okay, but thank you very much for everybody. I'll shut that down now. Thanks.
Thanks. Thanks, Ken. Thanks, everybody. We'll see you next month. Hopefully we'll be here next month. Happy holidays, everybody.